I'm very excited to have Simon. He's the co-founder, CTO of a company called V7 Labs, which is based in London. Like many of you, he's been working on deep learning for many years. Originally started an automated training data business using models to annotate data for computer vision. And most recently, him and a cracked team, as people tend to say nowadays, have shipped a new product called Go, which is a workplace automation system, kind of leveraging multimodal models. And I asked him to kind of give a back-scenes view of how they shipped this product, how they made use of multiple models and created something that's pretty robust, that's already growing pretty fast. So with that, thanks for your time, Simon.
Thank you, Nathan, and thank you, everyone, for coming. Yes, as Nathan said, this is going to be about Go, what happens behind the scenes, how it works. But before that, I'm going to give you some context. First of all, who am I? My name is Simon. I kind of started my AI journey when I co-founded iPoly back in 2015. So iPoly was this app to help visually impaired and blind to see. The way we were doing that was to run CNNs locally on smartphone. We were one of the first ones to get the CNN running at roughly 5 frames per second. And the idea is that when you detect an object, you just read it out, and then someone who's visually impaired can understand what's around them. And the way we did it was to build this really, really small ResNet models in a hierarchy where one model kind of decided what is the general thing that we're looking at. Oh, is this something this is a piece of clothing, or is this a kind of an environment? And they've had more specific models that we hot loaded on the phone to basically figure out exactly what we were doing. And even then, you know how you just get a bunch of different probabilities or softmax. We used a lot of code to stitch them together because the training data was so bad. So Mac and book was actually MacBook, but 2 different labels back in the day when we didn't really know how to label stuff. So besides making the phone really hot, we managed to do roughly 2 billion inferences on this platform. Now there are better applications. Microsoft is doing a really good job in the visual impaired space, but back in 2015, this was fairly novel. Then I moved to UK in 2018 and co-founded V7 with Alberto Rizzoli. And in V7, we were trying to take the learnings we had from building an AI company, training models, and help other customers build models to solve problems in a reliable way. And I think the reliable here is a key word, because to build reliable, especially computer vision models back then, what you need is supervised learning. So you need a lot of training data, good training data. And it's very time-consuming to create this training data. So we built a platform called Darwin. And Darwin kind of lets you manually annotate things, drawing polygons or bounding boxes. But what we really wanted to focus on is how can we automate as much as possible of this training or this labeling aspect. So what are kind of the first low-hanging fruits and then higher and higher hanging fruit that we can kind of reach for to reduce the amount of time someone needs to spend labeling? One thing to think of is for most tasks, not all tasks, the distribution of the kind of easy examples and the hard examples is that there's more of the easy examples. At least there are more of the common examples. That's why they are common. And what you do when you kind of start bootstrapping a new project is you start labeling a couple of 100 images. You train a model. It might not be a great model, just like my vector skills here, but it will get kind of the ball rolling. It will kind of pre-annotate the rest of your data set for all those easy examples. And then you can train an even better model. And the human just sits there as a reviewer and jumps in to do the things that are outside the distribution of what you're trying to do. So this is kind of trying to reduce the amount of work you need to do when the data comes in. There's another direction you can go, and that's to build tools for the annotator to speed up the annotation process as well. So here we have a tool that is more or less a foundation model where we have trained on a lot of different kinds of segmentations, and then we can basically create a polygon from a bounding box. Sam came out a few years later, and they're doing a fantastic job on the same and has a nice interactive element to it. But the goal here is to speed up the amount of time you need to spend before you get good labels. There are other things where we were trying to find everything else that has a similar embedding as the thing that you annotated, so you can annotate one thing and then you get everything else labeled. And this is something we released very recently. We start tracking things across multiple frames in videos. And this, you have no idea how time-consuming it is to write this manually. So having a model doing it for you saves hours. And the idea here is that to build these models that you can trust, you need good data. But all of a sudden, well, maybe not all of a sudden, but eventually we had these foundation models that were good enough that we don't always need to have a ton of training data to solve problems. And we still wanted to execute on a mission of helping companies solve tasks reliably and at scale. But now they don't always need to create a ton of data up front before they can start doing that. And that's when we started working on a new tool called Go. So foundation models are kind of like the foundation for what we're doing. And all of you have used them in ChatGPT or in applications you might even be building. And they are amazing in the sense that they work in areas that you might not have seen that much data for. But every now and then, you get results that are not maybe exactly what you anticipated. So here we say like a plate of pasta and what kind of lens we want the image to be taken in. While DALL-E 3 takes this a bit literally and actually puts a lens on it. And this is extra fun because as you might know, when you use the DALL-E 3 API, it rewrites the prompt for you. We're using an LLM before it sends into the diffusion model. So this is not really a problem when you use something like ChatGPT, because when you do talk to ChatGPT, it's a one-to-one conversation, right? You send some kind of query, show some kind of document, you get a response back. And if that response is off track, if it misunderstood what you were doing, then you just push it in the right direction. You just change your initial prompt, or you say, oh, no, I didn't mean that, I meant this. And then you're back on track, and then you can start doing things. This does not scale if you want to run thousands of similar processes in parallel, because you can't be there and manually watch each one of them, because it can go off track in different way for each one of these documents. So how do we solve tasks reliably at scale? And I'm going to show you some demos here of our product called Go. Here, we're basically creating, you can think of it as a spreadsheet with different columns. These columns we call properties. Each property is powered by either a foundation model, by code, by some kind of combination of it. We can use other kind of integrations where you can get data from. But essentially, it's a way to create a workflow where you can constrain the output at every step and make sure that you get data that you can work with. I'm going to show a kind of involved example here of building something from scratch, and then we're going to walk through it. So we're going to upload pitch documents. So we create a property for files, and then another property where we extract the CEO name from the file. And we upload the document, we wait a few seconds, and we should see the name, which is all good. Then we want to do something a bit more complicated. We want to understand, OK, what round are they raising? Is this Series A, Series B? Is this a seed? So we just add a bunch of finite set of different values that the model is allowed to generate. And then finally, we want to extract everyone who's the senior leadership in this pitch. And that's kind of we call them a collection because there's multiple values that could possibly be extracted. And you can give a prompt for what you want to do, and you say like, oh, here's kind of the date types. I want the name, I want the title. And then finally, we're asking for the amount of money raised to date. So like how much money have this, not how much you're looking to raise, but how much money have they raised up until this round. And you can see all this data is calculated. Then we will go and jump into this in a more like detailed view. We can see the senior leadership team. You can see the documents that we used to extract this data and the data extracted. And so this is Square, and it's an old pitch from like 10 years ago, maybe even older. And now we can start looking at the trust parts here. So here we are grounding the result of what we found to exactly where in the document, which pieces went into making this decision. And I'm going to go in on all of this in detail as we go through and how they work internally. And then we upload a bunch more pitches, and they all start calculating, we're getting the value, and we can start then acting on this data. There we go. I think I uploaded even more documents, but it's all the same. Let's talk a bit on how this works. So we have what we call a project or a spreadsheet. It has entities or rows and properties with other columns. The properties are essentially creating a DAG, a directed graph, without any cycles, where data is flowing from one property to another. But it's not just kind of the output of whatever you're seeing in the model that is flowing. It's a lot more, and I will jump into that in a second. The first thing I want to talk about is selects, single selects. It's a lot of the time we use LLMs, right? We get text back, or almost always. And this text is unbounded or bounded by context output, but it could be about anything. And the thing you want to do is kind of make sure that the data you're generating is constrained to this to a specific set of values that are okay for you to have. Let me give you an example. If I upload a bunch of invoices and I say, like, what is the category of this invoice? I would probably get, a category colon equals, and sometimes you see this star star, that means that it's markdown encoded. Basically, I need to go in and write a very specific prompt for me to get exactly the output I want, which is fine because we all know how to prompt things well. But if you want everyone to adopt this, we need to kind of lower the bar and make sure that people can get consistent outputs without having to be prompt engineers. So one thing you can do is just add categories into your data. And those categories can force the data to collapse into this finite set of possible outputs. And I don't think this is just about categories in general. I think this is about all the outputs you can have. You want to be very specific in saying that I want this to be a currency. I want this to be an email. I want this to be a JSON that has this schema that I want to be validated. I don't want to have to prompt that. I want that to happen automatically. Let's skip that. So what does it mean? It means that you have prompts that the user writes, but you can think of this more like a meta prompt. It's the intent of what you're trying to solve. Then you have the inputs. The inputs can be the files, images, videos, text from other properties. And then you send them into kind of a rewrite stage. And this rewrite stage depends a lot on the kind of property type you're trying to do. If you just want to get text, you do it in one way. If you want to get the select, if you want to get images, JSON, you do it in different ways. The way you can do this rewrite is basically combining the input and the prompts. Also depends on what kind of models are available to you, what the content length you have available to you, how big are the input files that you're trying to use, does the modality support of the model you're having cover all the files you're using. For example, Gemini supports certain things that GPT-4 doesn't support yet, and other models support even less, but then there are models that only support video. So how do we kind of polyfill for the misses between these things as well? So the easiest thing is just you use code to figure out like which pieces to pack together and then send it over to the LLM as just some kind of text string. And that works well for a lot of, like a big class of families. But as soon as your input gets too big, you might need to chunk the data. But then if you start chunking the data, you have to figure out like what kind of way am I going to sum it back together. You could think of it as like you're mapping the LLM across of all the inputs chunks. but then you need to sum this result. So it becomes a multiple step, and either you can fold up the data or you can do something else. You could drag embed the inputs, and depending on the prompt, you can figure out which subset of the data you want. But that doesn't work well in a lot of use cases, especially when you actually need to see all the data. If the prompt is like, hey, translate this from this language to that language, you don't want to drag embed it because you need all the data. Otherwise, you can't do the task. But then chunking becomes fairly easy unless you're kind of referring to something that happened a bunch of chunks before, and then you use different terms to translate those things. You can also sample inputs. Sample inputs is really, really cool. The idea here is that all the data in your input is not necessary for the task you're trying to solve. There's a really cool library called LLM Lingua that basically trains a GPT-2 model that goes through your model and just erases all the tokens it thinks is irrelevant to solve your problems. And GPT-2 is fairly cheap to run, so you can basically get up to a 20x speed boost in doing this. It doesn't always work. It depends on the context. And the last thing you can do as well, that is if you have old queries that you have done, and you somehow know that those queries were good, like the user said that, hey, that was a great query, or that was a bad query, you shouldn't have done that, you can use them as a library to inject either examples or counterexamples, or even better, change the prompt to something that does even better when you run the LLM. And this injection of examples, there are two different ways you can do this. You can either do it statically. So like I figure out I always want to use example A and example B because that works really well for me. Or I want to figure out which example to use depending on the input. So for each row, I might actually use different examples to improve the accuracy of my output. So this can be fairly complicated, especially figure out which one is the best. And we're not using all of this right now. But we have looked into all of them and we have experimented with it. And there's probably more ways of doing this than the ones I'm writing up here that we should explore. And that's something, if you have a good idea later, let's come and talk during the break. But basically, the core idea here is that if you just rewrite the input and the prompt from the user to something that is more specific for the specific use case you're trying to do, you're going to get much better results, and the user doesn't need to be that good at prompting. Let's skip that. And the second thing is that you also want to make sure that the output from the user or the output from the model corresponds to the class of things that you want it to output. For example, say that you're trying to generate JSON, right? So you have your LLM, you have somehow rewrite the prompt so it makes sense, and you get an output. If you have a schema for this JSON, you can check if this valid JSON or is it invalid JSON. And depending on that, you can then modify a query to run to the LLM right away. This does not mean that we're going to run for the same LLM. Makes sense. Sometimes you run for a much smaller LLM to solve a problem. Sometimes you actually need to abort because there's no way to fix this. A good example is, imagine that you have invoices and you have a number property. And the number property is like the total amount invoiced. And you are forcing it to say that it's a number. And the model comes and says, hey, total amount colon equals something. And you say, then that's not valid because it's not just a number. So then you send a message back to the model saying that this is not a number. I only want numbers, and then they're probably going to get it at the second try. Oh, okay, this is the number. Here's the number without any extra text around it. But if someone were to then upload a CV file or a grocery list or something similar that doesn't have any total amount, what do we want the model to do then? It would probably tell you, like, hey, I cannot output a number because it doesn't make sense. So you don't want to get stuck in a loop where you're trying to force the model to hallucinate something that fits within the data type you're trying to get. And I think what's going to be really powerful here going forward as well is structured generation. So structured generation is when you are kind of limiting which tokens are allowed to be used to create the output answer. So you can basically eliminate the whole class of issues by making sure that every token that gets generated creates a valid output. So if you only want numbers generated, you blank out all other tokens. If you want JSON that's always valid. You make sure that the first token is curly bracket, and the next token is only allowed to be things that would continue to be valid according to the JSON kind of schema. But then you have to be careful in the scenarios where there's no possible value that is valid. So you need to have an escape hatch for the model. Unfortunately, you can't do that with foundation models that you don't have access to directly, considering that OpenAI or Google are running Gemini. So we will just have to wait until they have some kind of API that lets us do that. Another thing that I think it's important is that we have a simple input. We could just send the image to a model and say, like, hey, do something with this. And we'll get fairly good results because models, most of these foundational models now are multimodal. But if you actually send the image, plus you have some other process running OCR, and then attach the text from the OCR, your results are better. And obviously, you could just run the OCR as well, but that would be even worse. So by combining different modalities as input, you can actually raise the bar for how much the model can do, even if they're both coming from the same source. In this way, you can also kind of polyfill the abilities that are missing from a model. Imagine that you want a model to, imagine you want to support audio, right? And you have a model that doesn't support audio. You can obviously run it through Whisper or something similar and get that data as text and then send it into a model, while a more multimodal model could take that data directly. But that multimodal model would do even better to take both the audio and the text as input. So there's a lot of different things you can experiment with here to get better results. Another aspect that is kind of important is corrections. So sometimes the models does things that are incorrect. So what I kind of showed here is that you can go in and then actually change the output of the model directly in the data. Then you can mark this by starring it as, hey, this is ground truth. You should not trust it. And then there's a lot of things you can start doing. Like the whole thing with the library, the old queries can come from this. Like the user has guaranteed that this is working. Let's start using this going forward. You can use it to automatically improve your prompts. You can do it for a lot of different things. So if you really want to want users to get a better experience, I think like I've seen a lot of applications via like a thumbs up, thumbs down when you have a conversation, and I think that sends a okay signal. But if you actually correct to the real value, that's a much stronger signal that you can then use to get better results. I touched a bit on grounding earlier. Often when we see grounding in RAG context, right? We have a list at the bottom of our query that shows here are all the chunks that we will use to give you the result. If you do a query on perplexity, you basically see like, oh, I've used this link, or that link. We're doing something slightly different that is a bit more computationally expensive. But every value here in this JSON output can actually be grounded to a specific thing, either in a graph, in a table, in the text. Which means that you can actually increase the amount of trust you can build in the system. And if there are stuff we can't ground, we will eventually be able to flag those as things that people need to take an extra look at before they continue with the system. Here's another example. This is a Wikipedia article instead about Anthropic. And then you can see a bunch of different data and how they kind of corresponds to what we're seeing here. And I think this key inside JSON prompt is basically, give me a JSON with interesting stuff from this page. And it's trying to make sure that it's always grounded into the data we're trying to have. Another thing we are exploring, and this is not released, is to basically talk to this product directly. So you can say, I want to analyze some files. OK, sure. Upload a file. And then you ask it, OK, what can you tell me about this file? So it reads from the file, it understands that it can extract things, it creates some new columns to do this work for you. And as you are doing this, you're actually creating a workflow without having to even know how to write prompts. So all you have to say, like, what your intent is, show some of the example data, and then you build out a number of different properties that can then start powering whatever we are trying to do. And yeah, I think that's on a loop. And here's another example. This is a slightly different topic. To make models do great things, I think they need access to code execution. When you want to sum values, when you want to make sure that computations are right, you shouldn't trust an LLM to do addition. You want to have some kind of code that can execute. So in the background, when we run GPT or Omni or Gemini and similar, we always have code execution in the background that can then execute and solve like the harder problems, like tool execution. But we can also then show this as something that the user can interact directly with. This is super early, and most users don't have access to this. It's behind a feature flag. But it kind of lets you build this, what should we call it? Almost like a Lambda execution directly. You can send your data, you get it executed within a second, and then you can start building pipelines of your data. So this is all generations of Pokemons, and now you can find like which has the which weigh the most, which ones are the fastest, and similar. But the cool thing here is not that you can actually build this in code, because that's fairly easy, right? The cool thing here is that the models are generating this code, caching them, and then running it at scale as you're starting to input data. So what I'm trying to get here at Go, the way we see Go is foundational models are here. They can generalize on a lot of tasks. You can start working on them without having any training data in the beginning. You build up these pipelines, either by writing prompts, but you're trying to be as kind of specific as possible on like the property types you're using, the agents you're using, and the code you're using. And then when you look at the output, you can start correcting it. And when you start correcting that, you are essentially training it. But you're not retraining it from scratch, because that would be extremely expensive. And you're not fine-tuning it, because it's hard to fine-tune proprietary models. But you're in this like slightly higher level where it's the input to the model that it gets tuned and that you work on. And that's why I think the sum of the parts here is greater than just the parts themselves. So we released Go 2 months ago. It's still very early. We got a lot of feedback from users, and we are continuously working on making this better. It's free up until a certain usage point, so feel free to go out and try it. And if you have any questions, catch me after the talk. Thank you.